All right, ladies and gentlemen, welcome back to this Athenian Stranger tutorial video where today we are going to continue our study of direct variation word problems. And in these word problems, we are going to do 6 different things to each one. So let's dive right in. In number 4, we're told a person's weekly pay is directly proportional to the number of hours worked. Shawn's pay is $123 for 20 hours work. Find the amount of pay for 31 hours of work. Okay, so these problems can all be solved using the butterfly method or cross multiply and divide. But that's not what we're trying to accomplish here. In this problem, or in these problems, we're trying to approach it more academically. So let's complete the series of steps. Step 1 is to write a rule. Okay, so what is our rule for this problem? What is our direct variation rule for this problem? Well, a hint will come when you find the language in the problem that indicates its direct variation. And the thing that indicates direct variation here is this phrase, is directly proportional to. Okay, so you might want to underline that. On the STAAR test, if you see that, you're automatically going to go into direct proportion, direct variation mode. So the rule here states that weekly pay is directly proportional to number of hours worked. So our rule, in plain English, is that the amount of money someone makes is directly proportional to the number of hours they work. And the way that we want to write this is we always want to write the dependent variable on top over the independent variable beneath. So we have to identify what the dependent and independent variables are. Well, we have 2 variables. So let's identify what those variables are, things that can change. Well, here's one of them, weekly pay. All right, and here's another one, number of hours worked. Okay, so this process of kind of deconstructing the problem is one that you'll get better at with time. Now, the weekly pay variable is the dependent variable because it cannot exist or its value cannot be determined until you know the number of hours someone worked. So we can say that the weekly pay is the dependent variable, and it's the variable that we would normally call y. Now, the number of hours worked is the independent variable, and that's because it drives the function, it drives the problem. It tells us we put this one in to our algorithm, our function, and out pops the dependent variable. So independent variable, that would be what we normally call the x variable. Okay, so I should add one more piece here. This would be the vertical axis, which I'll abbreviate as vert, and the independent variable will be the horizontal axis. Okay, so now we're really getting to it now. So we can fill in some information down in our rule. So we want the dependent variable over the independent variable. So we're going to say the rule is dependent over independent. Therefore, the rule for this problem, and here I'm using this symbol, 3 dots in a kind of triangular figure, we'll say that the weekly pay the weekly pay is directly proportional to the number of hours worked. Number hours worked. Okay, it might be helpful here to indicate that weekly pay is in dollars. And that the number of hours worked, well, that's in hours, okay, just so we understand. So we're looking for weekly pay and number of hours. So at this point, you know the English language relationship between the dependent and independent variable. This is your rule. So now we have to be given some data for the rule. It says here, Shawn's pay is $123 for 20 hours of work. So we need to go ahead and substitute actual numbers for our English language variable assignments. So in this case, we would substitute $123 as directly proportional to 20 hours of work. And from this, we can identify the constant of variation as 123 over 20. And this is what we would call the constant of variation. So this right here is important. This is the constant of variation. Okay, so we can label that as COV. So now let's see what we have here. We have our rule. And we have our constant of variation. So this is our rule. And this is our constant of variation. At all possible opportunities, you would attempt to simplify this number down. But you can't, the factors of 20 are, let's see, 2, 10, 5, 4. And those factors don't exist for 123. So it's a fully simplified, fully reduced fraction. So this is really it. And now we can move on to write an equation. Okay, so what is the equation that we're looking for? Well, the constant of variation is something that we assign the letter K. Okay, so you want to put that there as K. So when we're building an equation, we want to write y equals kx. Okay, so that's the general form of the equation. And what it basically says is the number of hours worked, or rather the weekly pay, is equal to the constant of variation times the number of hours worked. Another way to say it, the dependent variable is equal to the independent variable multiplied by the constant of variation. So we're going to substitute now K using our constant of variation. So we can say y equals 123 over 20 x. And now we have an equation, okay? So this should be tickling a certain part of your brain, and that part of your brain should be the part that knows about slope-intercept form equations of lines. So imagine the slope-intercept form equation y equals mx plus b. If you write that directly below your direct variation equation, you'll see that we're missing the plus b part, okay? Well, that just means that it's plus 0. The y-intercept of any direct variation equation is going to be the origin, okay, 0, 0. So the full equation, the y equals 123 over 20x plus 0. Of course, the plus 0 is just never written because it's understood. But until you're comfortable with it, it's fine to write it. Doesn't hurt anything. Now the next part is a graph. We need to draw a graph. And for this, I'm going to use a pencil. And I need that pencil to be very sharp because I'm going to try to be extremely precise. Mechanical pencil would probably work better here, but I don't have a mechanical pencil, and my students know that I prefer the old way better anyway. So you want to sharpen up a pencil so you can draw a nice precise graph. Okay, so for this, you will need a pencil, you'll need a straight edge, and that straight edge needs to have markings on it that you can use to build a graph. So let's build a graph over here, and we'll think about what we want. Before I start drawing the y-axis and the x-axis, let's think about what kind of graph we need. Okay, so here there's a number of ways you could draw a graph. You could draw it with 4 quadrants, like that. Okay, you could draw it with just the first quadrant shown. You could draw it with just the second quadrant shown, or even the third quadrant, or even the fourth quadrant shown. Okay, so you have to ask yourself, what type of graph do I really need? Well, look at your problem. We're talking about hours worked and weekly pay. All right, so you have to ask yourself, can the person earn a negative amount of money? No. So they can't earn negative money. So that means because money is the y-axis, we don't need anything negative on our y-axis. So these options are not necessary here. And then you have to ask yourself, can a person work negative hours? Okay, no. So we can get rid of these. All right, so now you're stuck with just this one. So we have a first quadrant graph that we need to draw. In other words, the domain and the range of this function, in other words, what possible x values can this function be the domain, would be only positive x values or 0, right? So it would be, the domain would be a closed-in circle like this, okay? The range would be a closed-in circle at 0 going up. So this is the domain and range of the function would be 0 to infinity in both the x and y dimensions. So now we go back to our graph. We know what shape of graph we're going to draw. So now we're going to draw a very precise graph. Try to make it as big as possible. Okay. And again, take your time with this. This is the important part. The predictive power of this graph will be dependent entirely upon how neatly you draw it and how precisely you draw it. So go in here and we know that this is the y-axis, this is the x-axis, and it starts at 0. Well, now we need to go and use the graduated points on our protractor or ruler or whatever it is you're using to kind of mark off a scale. So here I'm going to put in every 1/4 inch or every 1/8 inch on mine. Okay, see I've drawn these little hash marks, and I'll do the same scale on the x-axis. You know, some people say, well, this just takes too long. Yeah, I mean, it does take a long time, but as I've tried to explain in class, that there are some things in math that have a kind of artistic component to them where the amount of time you spend on it isn't supposed to be boring or punishing. You're just supposed to have fun with it and kind of enjoy the artistry of what you're doing. So, and the next problem we have to solve with this graph is what to put for these little hash marks. Well, now think about the biggest value we will need to plot on the y-axis. Well, we would need to plot 123, okay? But we might even plot bigger numbers than that. So you might want to go up to 200, right? So what would you make each one of these worth? Well, you can't make them worth 1 because then you'd only get at 1, 2, 3, 4, 5, 6, 7, 8, like to 20. So you're dealing with dollars. You know you need to get up to about 200 or so. So what are you going to make the graph? Well, you could make it in $10 increments, but how far would you get? If this 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120, 130, 140. And I'm not convinced that that's enough. So maybe there'll be $20 increments. All right, so let's see what that looks like. $20, okay, 40, 60, 80, 100, 120, 140, 160, 180, 200. Okay, that's good enough. We probably won't need to go higher than that, but you could if you needed to. And I'm going to turn the page now like this and label this y-axis. I'm going to label this y-axis weekly pay. Okay, weekly pay in dollars. Okay, so that's the money axis. Now we do the horizontal axis, which is hours, number of hours worked. So we have to figure out our scale here. Well, we're starting with 20, and we're going to have 31 we'll need to plot. So here I might do this one in increments of 2. Let's see. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30. Okay, all right. So here I'll do 2 hours, 4 hours, 6 hours, 8 hours, 10 hours, 12 hours, 14, 16, 18, 20, 22, 24, 26, 28, 30. And this axis will be hours worked. Okay, that's the independent variable. This is the dependent variable. This is the independent variable. So what we're going to do now is plot our equation that we came up with. And to do that, we have to start at the y-intercept. So the y-intercept of this is 0, 0. So I'm going to put a dot there. And now I'm going to go up the rise and over the run. So the rise is $123 and the run is 20 hours. Let me show you a way to do this that makes it ultra precise. So first, let's find 123. Now it's going to be essentially almost directly on this hash mark, but just above it. Just above it. So watch what I'm doing here. I'm going to take my protractor and I'm going to plot in a dotted, very lightly dotted horizontal line. It might not even be visible to the camera. You can barely see it there, okay? And now I'm going to plot in a vertical line dotted, very lightly dotted at 20 hours, okay? So here's the run, 20. Okay, now let me see if I pick this up, if you can see it. You see what I've drawn there? Where they intersect, so you go up the rise, over the run. Up the rise, over the run, so they would be intersecting right there. So you can put your second dot right at that intersection point. And then this will help you draw your line in. Again, the amount of time you spend on this, making it precise, the better the predictive power of the visual graph. So you draw in your line, and we can label this equation y equals 123 over 20x. Okay, so now what? It wants us to find out what the pay will be for 31 hours of work. So just visually, we can solve this problem by coming over here to where we see 30 hours and then look just a hair past it, because remember, this is 32. Halfway between 30 and 32 is 31, right? So we position our protractor vertically halfway between 30 and 32. And what you're going to do is you're going to draw a dotted vertical line all the way up to your equation line. Okay, just like that. And then you flip your protractor horizontally and you go read the y value associated with that hours worked. In other words, how much money does this person make if they work 31 hours? Okay, so this has got to be precise work. Again, I said mechanical pencil would probably work best here. But I see it's going to go hit the y-axis just below 200. Right there. Okay, so for 31 hours worked, I'm seeing something between 180 and 200, right? You could call it 190. Okay, that's the approximate amount of money that this person should make by working 31 hours would be about $190 if we drew our graph correctly. Now, if just the human hand, not with a non-mechanical pencil, can make these kind of small errors. It's all visual estimation, so we're going to confirm that, but our guess would be that by working 31 hours, we would make about $190. Let's see how close we are to being correct. So now we're going to go in here and find out precisely by plugging in 31. This is the x variable. This is the independent variable. Okay. This is the number of hours worked, 31. We'll plug that into our equation. And the way we're going to do that is using an English sentence. We're going to say if y equals 123 over 20 x. Okay, so that's true. We've established if that's the case, and x equals 31, then y equals 123 over 20 times, now here you're going to substitute in for x 31 times 31. Okay, so this is the equation we have to solve. We want to find out what y is in the weekly pay, and we're going to do that by multiplying 123/20ths by 31. Okay? So we have to go ahead and do this multiplication. 123 times 31. Three times 1 is 3. 2 times 1 is 2. 1 times 1 is 1. 3 times 3 is 9. 2 times 3 is 6. 1 times 3 is 3. Now we'll add these. 3, 11, 8, 3. Okay, so now our equation is y equals 3, 8, 1, 3 divided by 20. Okay. So if we were going to do this without the aid of a calculator, we would need to divide 3813 by 20. I don't really feel like doing that kind of basic math right now. So let's just help ourselves. And I remember I said you could do this. Go ahead and perform this basic math on a calculator. And remember, what are we hoping this is? We're hoping it's something between 180 and 200. Remember we said it would be like 190 something? Look at that. We got 190.65, which was almost exactly what we estimated it to be visually. And so this is a beautiful confirmation of the theory of graphing something. So y equals 190.65, right? And that goes in a box because this is the answer to the question. So I started numbering things over here. This first part was the rule. Okay, and that's the rule. The second part was the constant of variation. The third part was the equation. The fourth part was the graph. The fifth part was the work. And the sixth part was the answer. Is the answer correct? So remember, this would be 2 points, 2 points, 2 points, 2 points, 5 points, and 2 points, a total of 15 points. And this is a complete solution to number 4. And you could say, my God, this guy spent an absurd amount of time on this one question. Well, yes. I mean, yes, I did. I spent almost 30 minutes doing it. I think that once you understand the intricacies of the problem and how you go about thinking about the problem, that's when speed comes. I think a lot of students want the speed to be there initially. You know, right off the bat, you think a problem should not take more than 2-3 minutes. You'll get there, right? You could get there. You could produce this in 2 or 3 minutes. The hardest part would be trying to draw an accurate graph on a piece of paper in inside 2 or 3 minutes while also accomplishing these other things. But my advice is just to kind of kick back and turn off the clock and just kind of work the problem. And I kind of know that I'm singing into the wind here. We will go faster on these next problems, but I wanted to have at least a deep dive on one of them so that you could understand exactly what we were doing, especially this part over here. Drawing that graph and understanding what the graph actually means. Needless to say, you'll never have to do anything this complex on the STAAR test. You'd probably be asked to do one of the 6 things here on the STAAR test. But, you know, the ability to know how to do it, I hope it makes you proud. If you put in the time and you make this look very nice, I hope that you find that you're fulfilled from doing good work like this. Okay, so when we come back with the next video, we'll work through number 5. So thank you very much for watching. If you found this video helpful, please give it a like, hit that thumbs up. If you haven't subscribed already, please do so. And leave a comment, if you will, that boosts engagement, boosts the search rankings, and we'll be back here shortly with number 5. Thanks.